Here we have a question that gives us the graph of 3 to the power of x. And so we can see that graph in the back line here. And what we're asked to do first of all is to plot the inverse of this function. So I'm going to do some maths down the bottom, and we're going to get to what is the inverse. What is f minus 1 of x? Given that f of x originally is equal to 3x. Okay, so there is a log law to say if we've got something like log something base, and that is equal to a is equal to b, or I'll use another one, c, then b, right, b to the power of c is equal to a. So this is all totally a non-calc question. And what that means is that we're going to have to figure out the inverse ourselves. And what we can then say is these are the inverse functions of each other, okay? Because if you have something of log 3 to the 3, well, that's just equal to 1. That's the inverse. That's 1 divided by the other. So in logs, you can divide by each other by flipping between these two equations. So in our case, we're going to change it from 3x, where we now just, I guess, replace the values of x and y, right? So the inverse means that instead of having y is equal to 3x, we're now going to say, actually, let's swap them around. So x is now equal to 3y. So that's the inverse, and we need to use this above log law to get y is equal to. Otherwise, we can't plot it. It's really difficult. So we're going to use the above law here and flip them around. So going from here to here, that is your f minus 1. That's what we've done there. And now we need to use some math magic to say y is equal to. Okay? So we know that the base b is equal to 3. Let me draw my 3 properly. And we know that the x now goes into here. Perfect. So that's the function that we're going to draw, this function here, and that is equal to our inverse function. Okay, let's scroll up to the graph and we can draw it on there. I'm just going to use, let's say, green. Okay, so what is important about this one is that when x is equal to 3, all right, so for our equation here, so log of 3, and when x is equal to 3, that's equal to 1. All right, like we said before. So we can draw that data point in now. So when we're 3 across, and we go 1 up, okay? Now, what happens here? Well, if we have anything to the power of 0, so I guess 2 to the power of 0, that's also equal to 1. So what we can say is that when log base 3, when the x is equal to 1, that gives us the 0. Okay? So in that case, we can say when x is equal to 1, we're at 0. So now we've got this point here. Okay? And so that's important because that'll give us the trend of the graph here. So now log kind of mirrors it. It should mirror along this white, like this this dotted line here. So we can go up and around like this. And this is our equation here. This is f minus 1 x. So now we're just going to leave it at that, and we're going to go to part B, which is asking us what happens if we now have a minus 3. So what happens there? Well, let's take another example where we say g of x is equal to x. All right, we all know that will just give us a straight line. If I can draw my line properly. But if I say g and I say x minus 3, so whenever I see the value here, I'm going to minus by 3, okay? So the shortcut method is, I'll just put in a value here, so x minus 3. So that means at point 0, right? If we say g of 0 minus 3, well, that would mean that it is just going to be equal to minus 3. So it's kind of like down here now. And if we do that for every point, we see that it looks like it's moved it to the right. And that's exactly it. So when it's inside the bracket and you've got a minus sign, you can say it's behind closed doors, so it's not what you think. It's behind the bracket, so it's not what you think. So if it's a minus, it moves it to the right. Okay, and that's because it needs, you can, as you can see, it like takes away 3, so it shifts it shifts it down in this case, but also it's moving it to the right in most cases. So behind closed doors, not what you think, it's opposite, and so that means that it's to the right. So in this case, we're going to draw the exact same function as we did in green, but we're just going to move it 3 units to the right. Now I'm going to use my function in red. So this is going to be 1, 2, 3. And so really we're only going to be able to draw, we're only really going to be able to draw this little bit here. Okay, so not too much on there, but just to make it a little bit better, it should mainly be like this. Okay, and so this is our function here, f minus 1, x minus 3. Okay, so that's how we do it. It moves to the right. So that's all about our translations in the left and right. Let's go to the next question, which has been kind of hidden here. But this is saying what happens if I plus 2 and then minus our function. So first of all, if we have a minus, that means that every function is going to flip about this x-axis here. Now this x-axis I'm going to draw in purple here. Okay, so this green one is going to flip about that. Okay, so normally it'll just flip about that and it'll mirror it. So we kind of get this looking thing. Okay, but we're also saying that we're going to add 2 to it, right? Because if we go back down to the part C, we're going to add 2 to it. So that means that for every point, we're going to plus 2. So it goes 1, 2. And so for every point we do that. So the key point here that we're going to look at is this guy here. Now I'm going to change color. Well, let's go purple. And so now we say that this function is going kind of through here like this. Maybe I'll draw that a bit better. So it goes through here and up around like that, and then across like that. And this function is going to be f minus 1 of x, okay, with a minus sign in front and a plus 2. So that's how you do it. That's how you draw these functions. There are so many questions like this, exam level questions that are on my website that'll help you get the best marks. So click into the description and see which questions you're struggling with. If you have any questions, reach out. We'd be happy to help.